Hi everyone, welcome back to the channel. This is the IB Computer Science series where we cover the entire new CS syllabus in the most simple, clear, and exam-oriented way. So today's video focuses on chapter A1, that is Computer Fundamentals. I'll just show you the PDF of the textbook which I have with me. Yeah, we're gonna focus on this Computer Fundamentals. And in today's lesson, we're gonna try to cover the first three portions, that is 1.1, 1.2, and 1.3. We'll try to make as many videos as possible to complete the entire syllabus. So we'll complete 1.1 to 1.3 in today's lecture. Okay. By the end of the video, you'll understand CPU, GPU, and the different types of memory concepts. And hopefully, IB will be a pleasant one for you. So without wasting much time, let's start. So let's start with the brain of the computer, the CPU. So what are the things you need to know when we discuss about the term CPU? So I'll just move on to my whiteboard. Okay, hold on a sec. Yeah. So what are the important components you have to know here? The first component you have to know is ALU, which stands for Arithmetic Logic Unit. The next thing you want to know is CU, the control unit. Next, you need to know about registers, buses, and cache memory. So we're gonna discuss about arithmetic logic unit, control unit, registers, buses, and cache memory. Okay, so now let's break this down. Let's start with the very first one, that is ALU. So what is ALU now? So ALU is responsible for mathematical and logical operations. Anything like addition, subtraction, and or comparisons all happen inside the ALU. So if you think a CPU as a human, ALU would be the calculator part of your brain. So any type of operations, if you do like something like 7 plus 6, this comes under the ALU. You do like 7 negative 2, comes under the ALU. Or if you want to do 7 ampersand 2, or let's say 7 right shift 1, all of these things come under the arithmetic logical unit. Fine, that's it. Don't worry, we'll provide the notes at the description box for your benefit. But my goal is to make sure you guys get the concept clear in your mind. You get it? Fine? Good. The next thing we're going to discuss about is the control unit. Now, what is a control unit? So you can think that control unit is the manager. So this part doesn't do calculations, but it controls the flow of instructions. Now, it's just not like that we just do calculations and the CPU is done. No, you have to control the flow of instructions. There are many other activities which a CPU needs to perform other than calculations. So who makes sure control flow and other activities are performed clearly? By the control unit or CU. So you can say CU is like a manager. So if I write it here, you can say CU is like the manager. Clear? Fine. Now the next thing we're going to discuss about is registers, and probably this is the most important part, and definitely you're going to get a lot of questions for this one. Okay, so I'll just erase the screen. Okay, now what is a register? So there are some key points you have to keep in mind. Always keep in mind, in computer science, it's all about the key points, nothing else. Okay, if key points are there, you're going to get marks. So what is the registers exactly known as? So we can say the first point as they are ultra fast memory location. First important one. The ultra fast memory location. What is the second point? The second point you can say about a register is that they provide you quick access. So ultra fast memory location and quick access. Now, what are the three different components you have to study here? First, you have to study is PC, or we call it program counter. The next you're gonna study is MAR, which is the memory address register, and then ACC, which is the accumulator. Okay. Now let's discuss about them one after another. So what is a PC now? PC is basically what it stores the address of the next instruction. So let's say if there is instruction A, B, C, D. So how does it work? So what is the first instruction? A. So PC will store A. Let's say this is done. Then PC will point to this. Why will it point to this? Because this is the current instruction. This way it's processed. So if the key point you ask me for program counter is stores address of the next instruction. Now what exactly is an MAR now? The MAR is what we call data registers. So what do you mean by a data register now? Data register is simply nothing but we store the memory address. Now what do you mean by memory address? Now take a real life example. You guys live in some part of the world, right? I'm from India. You guys can live from anywhere around the globe. So wherever you live, you need to have an address, right? Obviously, without an address, how can I locate you? Let's say you are from the United Kingdom. So I need to know which part of United Kingdom you live at. You just can't tell me that, hey sir, I live in United Kingdom. That's not the case. You have to tell me which exact part of United Kingdom and more precisely what house number, what street number do you live at. So MAR is exactly the same thing. You need to give an address to your register. Okay, next. Next we're gonna discuss about is an accumulator. And probably you can say this is the most important part when it comes to registers, and we get a lot of questions on this. So what exactly is an accumulator? It's a very special kind of register inside the CPU which stores the intermediate result. Yes, this is the key point. Stores intermediate results. So it does what? It stores intermediate results. And what will happen if you store intermediate results? So let's say you perform a calculation like this. Just for example, A plus B into C minus D slash E, something like this. So if you follow the BODMAS principle, if you do D by E first, then B into C next, then you after doing this you like add up A plus this term. Let's say I combine B into C as Q and D by E as Y. So accumulator says that I will temporarily hold one of the operations. So A plus Q. I mean Q will have B into C, but it will be stored in where? In Q. And Q is what? Now Q is what equal to an accumulator. It stores intermediate results, not the final results, the intermediate results. Okay, that's it. And then arises the next part, which is the fetch, decode, and execute cycle. How does the fetch, decode, execute cycle occur? There are three main points for it. I'll just show you one. Let me raise the screen. So the first point is ALU takes the value from ACC. Next, performs the operation. Third is stores the results back into ACC. And all of these three is what we call the fetch, decode, execute. And this is what a cycle. It goes on again and again. Don't worry, we're gonna provide you detailed notes at the description box which you can read. My notes will be specifically based on the key point. As I said, it's not English, it's computer science. You need the key points. Even if your answer fits like 3, 4 lines, you're gonna still get a 5 or 6 marks if the question carries that, because all matters is key points. Clear? So that's all about registers. Now we're gonna discuss about the next one, that is buses. Now buses is important. There are three intermediate. Okay, first let me tell you what is exactly is buses. So the CP communicates using buses. Now I'll show this with the help of a diagram. Okay, I'll just erase this one. Okay. Think about in this way. So for example, if you have like A, B, C. Now let's say you say I want to communicate from A to B, or from A to C, or from B to C, or A to C, something like that. So who will help me to establish the communication? So if I want to establish a communication from A to B, this line or this communication channel which A and B creates is what we call bus. If I connect from E to C, this is also a bus. If we connect from C to B, this is also a bus. So bus is basically what? In simple terms, bus is like a communication highway. A communication highway. Now, what do you mean now by a communication highway? Basically, connecting two parts. Okay. Now, there are three important parts, very simple parts. Data bus, which basically means what? Transfers actual data. Now, what do you mean by actual data? The real important data. So, if you have a big chunk of data set where you want to transfer all the names of the candidates along with their uh, IP addresses, so these exact minute clear details, which we call actual data, is transferred by who? The data bus. The next one you have is the address bus. Now, what is an address bus? Basically, meaning it indicates memory location. Now, what do you mean by this? Simple. Look at my diagram. A is the memory location, B is the memory location, C is the memory location. So who is helping us to make sure from where to where I should transfer? The address bus. That means A is an address bus, P is an address bus. I am tracking the location where I want to send. And the last and the most important one is control bus. That is sends command signals. Signals. What do you mean by this? So it's like I want to connect A and B, but I can't connect like that. So I will send what? A command signal like this. Then the address bus from A to B will be connected. And when I send something from A to B, that's what we call a data bus. That means transferring the actual data. And that's all about buses. It's clear, right? Perfect. All right. The last part is the cache memory. The cache memory. So if I tell you in general what is cache, the key point for it, it's a small, you can say a very fast memory. If you want an example, open any application on your mobile, click on app info. You're gonna see some message like clear cache, cache data is this, you want to clear this or not. So this cache means what? It's a very small, a fast memory, and this is present near the CPU. Most important keyword, near the CPU. Now, what is this used for? Like, you can ask me what is the purpose. So if you ask me the purpose for it, the purpose is stores frequently used instructions. Okay, and why does it frequently use instruction? To speed up processing. You have an account open in an application. For example, if we take Twitter, it says cache memory of 1 GB is stored. What does this mean? That means you are using this particular account for a very long time. You have stored the username, password, all the things you have done till now, and is accumulated as a cache. Now you can have a question: if I delete cache, will my system get corrupt? No, that's not the case. If you delete cache, there are two positive sides and negative signs also. Positive in the sense that you're gonna get some more memory space, but the worst part is once you delete cache, you have to make the application re-understand who you are, like re-log in from from the start and everything. It will not technically. It's not like it will forget everything. It gonna remember anything, everything. Only difference is you have to technically make him realize who am I. Then only it will understand. Okay. So there are three levels of caches in your syllabus. They exactly don't come, but still I'll tell you. There are L1 cache, which is what we call the fastest one, and they are the smallest one also. Then we have the L2. They are like slightly slower, slightly slower than the L1, and they are larger. And the last we have is L3, shared between cores. That means these are shared between cores. And that's all about the five types of CPU, like CPU components: ALU, CU, registers, buses, and cache memory. I hope you get it. Fine. Let's quickly discuss about GPU along with the difference between a CPU and a GPU, and then we can continue again in the next video. I'm gonna erase this. Fine. So let's discuss about GPU. So what is a GPU? You would have heard this term a lot of times when you refer to any gaming applications. So what does GPU mean? GPU is something which is okay. Let me write GPU first. GPU. Okay. So what GPU is mostly specialized at? Specializes in parallel processing. Okay. Now, what exactly parallel processing means? I mean, how can it help? So the first one performs thousands of simple calculations at the same time. Then, what are the operations it does? I mean, it completes. The first one is graphics rendering. The next one is matrix multiplication. The next is machine learning, and this part is already there in the syllabus as a separate topic. We're going to discuss that. And next, physics simulations. Another thing that it really helps you is in gaming. If you want to play a very high graphic game, GPU is mandatory. I mean, every computer should have a GPU, but you need a very high GPU to process that. Now, the big difference. What is the difference between a CPU and a GPU? The first important point is GPU is based on parallel processing, but CPU is based on serial processing. That means it completes one complex task one at a time. It's not like you're gonna give it three tasks, CPU will do it all together at the same time. No, it performs one at a time. First task A, then B, then C. But GPU, on the other hand, do all of them together. And this introduces us to the next concept, that is what we call pipelining, which you have in this particular chapter only. We're going to discuss it probably in the next or the third video. It's a simple concept. No need to think about it now. The next difference between them, apart from this part, is a CPU is generally made up of strong cores. It is made up of a strong core, in the sense a large number of cores, compared to GPU. GPU are made up of weaker cores, less number of cores. And if you ask me what exactly is CPU and GPU good at, so CPU is very good in the case of sequential tasks, task performing one at a time. As I said you earlier, also GPU is good for performing parallel tasks. If you want to do three applications together at the same moment of time, the GPU will be the most handy one coming into action at that particular moment of time. Now, if you ask me, sir, which is more versatile? Obviously, it's CPU, our very own CPU. CPU is more versatile, but GPU is basically used for repetitive workloads to speed up repetitive workloads. If you want to play something like a game with a very high graphics, and you know that the game components are designed in such a way to handle the high amount of graphics, the high data processing happening at the back end, CPU alone can't help. You need a GPU that will help you to speed up your repetitive workloads. And that's it. Don't worry. We'll attach all the notes in the description which is required. But my motive of making this video is you guys get clear about what exactly does this portion mean, like what we discussed about registers, ALU, CU, cache memory over here, GPU, CPU, the difference between them. You get an idea because computer science is all about getting the idea clear. Once your idea is clear, you're fine with it. Okay, so we'll keep it till this. Uh, Congratulations. Now you understand the basics of computer fundamentals. We have covered till CPU versus GPU, like till 1.3. We're gonna discuss about the next parts in next video. If you found this video helpful, don't forget to like, subscribe, and use this playlist to revise for your IB exams. See you in the next class. Thank you.